Chapter 4 Conics 4.3 Parabola Part 2. By the end of the lesson, students are able to determine the vertex, focus, and directrix of the parabola by using completing the square from the general form to obtain the standard form. Let us take a look at the example. Write down the equation of the parabola before in a standard form and state the coordinate of the vertex, focus, and also the equation of directrix. Lastly, we need to sketch a graph. So what we have to do is applying the completing the square. From here, did you notice that this is something variable x and y, only the variable x in square form. So it means the completing the square are going to do for the x. So we're just doing something x and x, y and y. Constant, put it right hand side. So we make it x squared minus 8x equals to negative 4y minus 12. So my dear, the right hand side we no need to simplify it first, because after we do the completing the square, we will obtain a constant number again. So what you have to do right now is focus on the left hand side. Okay, as we know that we are having a bigger bracket square minus a smaller bracket square, and the right hand side we just copy down before we obtain the constant number at the left side. And after that, it will be the coefficient of x divided by 2, which is negative 4. So this is x minus 4. So we will get that x minus 4 squared equals to negative 4y minus 12. So as we know that this one we obtain is a negative 16. So it will become plus 16 at the right side. So lastly, we get that the final constant number is a positive 4. So as we know that if you want to comparing with the standard form, so the standard form for the x, it should be x minus h squared equals to 4p. Inside the bracket, the coefficient of y must be positive. Therefore, from here, we get to know that this is a negative 4. So we need to factorize out the negative 4, and you will obtain the y minus 1, and the left hand side is still remain the same as the x minus 4 squared. Okay, so once you get the standard form, obviously the vertex is equals to 4, 1. 4p is equals to 4 or negative 4. So you have to be careful with it. So here, after we factorize out, it's a negative 4. Okay? Because the values of p, positive and negative, will give a different pattern. So when you get a p equals to negative 4, where it's less than 0, it should be open down or open left. So x is the square form, so it means it will be open downward. Okay? So we can get to know open downward is mean the changes of the focus is in y coordinate. Therefore, the focus, it will be h k plus p. Don't worry, the values it must be always positive because of the p is negative. When plus something negative, it will moving down. Okay, so that's why it must be k plus p. So it will be 4, 1 plus negative 1. Okay, so the focus point is 4, 0. Okay, so the vertex, we already get it. Focus, we already get it. We still left another components, which is the equation of directrix. So the equation of directrix just follow the changes of the p at the y coordinate. So when changing at the y coordinate, it will be y equals to k minus p. So the k is 1 and the p is negative 1. So we get that is a positive 2. Okay, so y equals to positive 2 as a directrix. Lastly, let us sketch a graph together. From the part 1 video, I believe that most of the students, you are able to sketch a graph and also label all the components. Okay, and the vertex is 4, 1. Okay, so we label as a 4, 1. And the focus, logic thinking, the y coordinate should be going down, right? So the focus is a 4, 0. So it means different 1 unit. And the directrix line, it would be, so we try to draw it symmetrical, and also the distance p from the vertex to the directrix, and also the distance from the vertex to the focus, try to make it equidistant. Okay, but you don't need to label it. Okay, you don't need to mention as equidistant, but logically they should equidistant from the vertex point. And lastly, do not forget we need to label the x-axis and y-axis. So since just now here you already obtained that 4, 0, so it means in terms of y this is a 0, but in terms of x it will be moving to the left. So maybe it's around here. Okay. Yeah, and do not forget to label the x and y. So you get it. It's very simple. So the example B in the lecture notes, you can give it a try. So which is then the y is in terms of square form, how it looks like. Okay, so you give it a try for the example 13b. Okay, let us proceed to another example. Find the equation of parabola which is satisfied the following condition. So from the part 1 parabola, we just obtained open to the left, but now the situation a little bit different. So let us take a look what is given here. The vertex is -1, -2, so this is a HK. Okay, so these two numbers settle. The axis is parallel to y-axis. Do you still remember parallel to y-axis? So you can try to draw a y-axis. If you want to make the y-axis as an axis of symmetry, so it's either open upward or open downward. Only can say that the parabola is parallel with the y-axis. So these two pattern is giving us the equation should be x minus h squared equals to 4p y minus k. And now you have the points passes through at 3, 6. So it's maybe around here because we're not sure which one. Okay, we only can determine whether it's open upward or downward by figure out the p values. So what we're going to do now is substitute the h and also the k into the chosen formula. So here will become x plus 1 squared equals to 4p y plus 2. As usual, I already mentioned to you that x and y is a random point values from the parabola. So now we substitute the 3 into the x and also substitute the 6 into the y. So you will obtain the values of p. So this one you will get 16 and this one you will get 4 times with 8 will be 32p. So the p is equals to positive 1 over 2, yeah, which is greater than 0. So it will be open upward but it's not downward. Okay, so lastly the equation of parabola is x plus 1 squared equals to 4 times with p, which is a 1 over 2, y plus 2. So lastly is equals to 2y plus 2. So this is the equation of parabola that we obtain from this situation.